Working on some examples using the angle theorems. So when you learn these, you've got to remember that there are one, and this angle theorem, the first one you can view it 4 different ways. Angle theorem number 2, which is angle in a semicircle is a right angle. Angle theorem 1, angle at the centre is twice the angle at the circumference, subtended by the same arc. And angle theorem 3 is angles in the same segment or equal arcs or chords subtend equal angles at the circumference. So let's write down what these are just for practice. So this is the angle at the centre is twice the angle at the circumference subtended by the same arc. Remember, you can see it 4 different ways. The bottom right hand diagram is the easiest. Here they can sort of be side by side, but that angle there is at the circumference. So every time you see an arc and you see angles coming off it, you should always do this. Okay, then this one, that's at the center, that's at the circumference. They're all on that same arc. So they're all standing on this same arc there, this arc here, this arc here. The first 3 aren't a problem, but now you've got to see which arc these are standing on. See, because there's your arc, there's your angle, right? So this is your arc here. You can tell by this angle up here. This is your arc here. When you've got that reflex one in the middle, it's always by the major arc. So that and that. They're both, see, underneath what you're drawing. Okay, so just be careful with that reflex one. So that was theorem 3. This is theorem 4, I think. Yes, the angle in a semicircle is a right angle. And theorem 5 we've got 2 theorems here. I'm going to do the first one. Angles in the same segment. Angles in the same segment of a circle are equal. Or you can write it as angles at the circumference subtended by the same arc are equal. Or chord, so subtended by the same arc, and I'm going to put in brackets or chord are equal. So they are for the first diagram. And for the second diagram, equal arcs or chords subtend or you can write angles at the circumference subtended by equal arcs or chords are equal, or you can say equal arcs or chords subtend equal angles at the circumference. You can say it either way. One's the converse. So equal arcs or chords subtend equal angles at the circumference. I've written it one way. I think when we wrote the theorem in your other booklet, we've written it the other way. But it depends what they give you. If they give you the chord, you can say, well, the angles are equal. If they give you the angles, you can say, well, the chords are equal. Okay? Page 5 in the booklet, find the values of the pronumerals, giving your reasons. So what would the first one be? What's beta equal to? Yeah, it's 2 times 109 degrees, which is 218 degrees. Reason. So we're just practicing recognizing the different reasons. Yeah, angle at the center is twice the angle at the circumference. Subtended by the same arc. Okay, and keep going now. arc BC. It's the major arc BC. But if you're be okay with the second one, beta is what? What's beta? Yeah, again, same reason. Angle at the center is twice the angle at the circumference. I'm just going to put that. It's tended by the same arc AB this time.
Week 8, is that?
Yes, that's okay.
73 angles in the same segment if you want. That's it, easy. Or angles at the circumference subtended by the same arc are equal. So the two angles are at the circumference. And beta is 23. Again, angles in the same segment. Or do you want to write it the other way, or you're fine? Similarly. Or I'll write it the other way. Angles at the circumference, just so that you can see the two ways of writing it. Subtended by the same arc, but they're the same reason. They're the same reason. So they are the same reason, but they're done on different arcs. So the beta one is done on the red arc, okay? And the alpha one is done on the blue arc, okay? You okay with that? Oh, 26. Sorry. Okay. What have we got? It looks like the 305 is there. Now, there is no other angle coming in this way. So you're going to have to find something else first. I know that reflex angle BOC is 305. Come on, what's this little bit? Don't forget your... So angle BOC, not reflex, but acute. Acute angle BOC is what? 55. It's 360 minus 305, which is 55 degrees, angle sum at a point. So we know that's 55, and now you can work out the others. So what can you do now? Angle, alpha. So therefore, alpha is what? 55 divided by 2? 20 what? 27.5 degrees. Again, angle at the center is twice the angle at the circumference. And beta is the same as well. Similarly. Or you could have done that alpha equals beta by angles in the same segment if you want. So girls, beta, you could have done beta is 27.5 similarly. Do you know what I mean? Or you could have done that alpha is beta by angles in the same segment if you want. You okay? Or I could have done alpha equals beta is 27.5 degrees with angles in the same segment. So more than one way to do this. So I could have done it with angle at the center is twice angle at the circumference, or the other way. Okay? So keep going. Angle at the center is twice the angle at the circumference. Subtended by, which arc is it for this one? It's by the major arc this time. Major arc AC. It's the major arc AC for that first one. So we've got the 280 and the alpha. They go together with the red arc. Okay? Now, then we've got this and that. They're by minor arc AC. So what do I need to do next? Angle AOC, the acute out one, is what? What's acute angle AOC? So, yes, it's 360 minus 280, which is 80. And that's angle sum at a point. And so therefore beta is, so this is 80 in blue. Beta is 80 divided by 2, which is 40. Reason, angle at the center is twice the angle at circumference. Subtended by, this time, the minor arc AC. AOC is 360 minus 115, which is 245 degrees, angle sum at a point. It says there that beta would be 122.5 degrees because the angle at the center is twice the angle at the circumference, subtended by the major arc, this time, major arc AC. Okay? Chords, those two. And they subtend equal angles at the circumference. So alpha will be 40 degrees because equal chords subtend equal angles at the circumference. X by angle sum of triangle. Girls, so let angle, did someone let something equal theta or something? Let angle BAC equal theta. Yeah, that's good to make the smaller one theta. Therefore, angle, so what can we do? Angle BOC is what? 2 theta is 2 times angle BAC, which is 2 theta. Reason? Angle at the center is twice the angle at the circumference. I don't know, I'm just doing it whichever way I can see. Okay. Triangle. So now we need to find the size of angle OCA. Now OCA is also theta, but there are 2 reasons you could use. You could say that OA equals OC, that it's an isosceles triangle, base angles of isosceles triangle, or you can just say that that theta plus theta is 2 theta by exterior angle of a triangle. So I'm going to put that it's 2 theta minus theta. Actually, I'll put it in brackets how we did it. It's angle BOC minus angle OAC. That's with exterior angle. Exterior angle of triangle OAC equals sum of the 2 interior opposite angles. So therefore we can see that angle BOC equals 2 times angle OCA. Because BOC is 2 alpha and OCA is, sorry, theta, and OCA is, one of them's 2 theta, the other one's 2 theta. Sorry, this one's theta, that one's 2 theta. So it's 2 times, you can see it there. C is 90 degrees, angle in a semicircle is a right angle, and alpha will be 51 degrees by angle sum of triangle. And you can, now we've got a length question in question 4. Question 4, ABC is a right angle, angle ABC is a right angle, and therefore you can now apply Pythagoras' theorem, okay? And you'll get root 77. Answers now, alpha is 52. You can see your equal angles at the circumference subtended by the same arc CD are equal. And here we've got our equal chords. Beta is 47, subtend equal angles at the circumference. It's for 3 and 4. We've got angles in the same segment, or angles at the circumference subtended on the same arc, by the same arc for beta. And then angle at the center is twice angle at the circumference. And 4, you've got to work out that obtuse angle there. And then you can do angle at the center is twice angle at the circumference, and angles in the same segment to say why each one's equal, or that should be fine. Vertically opposite angles. Then we've got angle sum of triangle for beta is 30, and then alpha equals beta because they're both standing on the same arc AD, angles at the circumference subtended by the same arc AD. With 6, we've got that alpha is 45 degrees because those two equal chords subtend equal angles at the circumference. And if you look at alpha and beta, even though one's over there and one's over there, they are both subtended by the same chord, by this chord here. Okay, so alpha equals beta because they're both standing on that chord down there, which I've just so there's your alpha angle and there's your beta angle. Okay, so they're both standing on this chord here. Okay, see, and I'm looking now, I can look here as well. I can see that x is 35 straight away. Look, there and there. It's my favorite one. Angles at the circumference subtended by the same arc. So beta is 75 degrees. You can put angles in the same segment or angles at the circumference subtended by the same arc. Now the arc in this case, I'm going to call it arc ABC because it goes that way around. It tells you which way around it goes. Arc ABC are equal because the endpoints of the arc are A and C. Then you can also do X the same way. So I'm outlining that one in blue. X and 35. So X equals 35 degrees. Similarly, I'm just going to put similarly because it's the same reason, but by arc, that one's not mentioned. A, B, C, D, E, F, let's call it point G. By arc D, C, G, I think that point came off. I've called it point G. Okay. Similarly, by arc D, C, G. Right. And what else? Alpha. Alpha's not standing on an arc. So alpha is the exterior angle. So alpha plus 35 degrees is 75 degrees. So alpha is 40 degrees. The exterior angle of triangle equals the sum of the two interior opposite angles. So we've got alpha. What are we missing? Theta is another exterior angle. Theta is the exterior angle of this other triangle. Can you see it? Theta plus 90 is 122. Similarly, in other words, theta is 32 degrees. So given that CE is 6.5 and BE is 1.2 and BA is 1.7, and you have to prove that the two triangles are similar and hence find the value of y correct to 1 decimal place. Okay, off you go. You're proving that they're similar. We've got vertically opposite. We've got angles at the circumference subtended by the same arc. That would be enough for equiangular, but just for practice, we're going to do these reverse angles here. The two crosses are also standing on the same arc, but the arc is BC, and the two triangles are similar by equiangular, and we can do ratio of corresponding sides, and you will end up with y is 9.2 centimeters.